Okay. If you were here literally 5 seconds ago, but it took me 30 minutes to figure this out, figure something else out unrelated. Different current. So different amount of amps at different points. Okay? In a parallel circuit, oh my goodness. Oh my god. Okay, in a parallel circuit, when you add resistors, resistors are like light bulbs or things that are resisting the current. Because if I have a current here and I had no light bulb, it would just go around and around and around. But because there's a light bulb here, it's resisting the current a little bit. And each light bulb has a different resistance, okay? Or every resistor. So, for example, when we talk about here in this parallel circuit, this can have a resistance of 10, and this can have a resistance of 20. And that will dictate the speed at which the current moves. So when you add a resistor in a parallel circuit, the total resistance goes down. And so let's think about this. Okay. When we're here, let's talk about versus the series where it's in a row. Here, when you add a resistor, here, it still has to go through this in order to pass through. Right? So if you're going, you need to pass through this, and then you have to pass through this, and then you have to go around. So this, when you add a resistor to a series, the total resistance goes up because if I added another one, then the current would have to go through this one as well. But here, it's getting split up. So the total resistance goes down because if this is going too slow, then I'll just go here. And if I add another one, if this is going slow, then I'll go here. Right? It's like if you added another lane at the checkout. Versus here, you just have three little idiots who don't know what they're doing and they're taking up a lot of time. And so the line is getting clogged and clogged and clogged and clogged and clogged. And the resistance goes up. And then, because the resistance goes up, the current slows down. But here, you're splitting up the work. Okay? And that's all that is.